Hi, I'm Patrick Regan. Welcome to Networking Part 5, Wireless Networking Part 1. During this video, we'll cover the various wireless standards and technology that make up the wireless network, including discussing access points and wireless routers. We'll also cover radio frequency identification, or RFID. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Wireless technology provides the ability to communicate between two or more entities over distances without the use of wires or cables of any sort. Most wireless networks use radio waves. Another form of wireless uses microwaves. The most common network connections is the 802.11 Wi-Fi. Bluetooth is usually used to allow access to local devices to form a personal area network. 802.11 Wi-Fi and Bluetooth use radio waves. The radio waves have the frequency range of 3 kHz to 1 GHz. These waves are easy to generate and they can travel along long distances. These waves are omnidirectional in nature, which means that they can travel in all directions. They can penetrate through normal walls very easily. They're used for AM and FM radio, television, cellular phones, and wireless 802.11 Wi-Fi. The 802.11 Wi-Fi 2.4 GHz radio signals up to 150 feet indoors and 300 feet outdoors, while 5 GHz signals have a short range of 50 feet indoors but offer faster speeds. One type of wireless networks that is based on radio waves is cellular broadband. Cellular broadband, such as 4G and 5G, uses mobile networks for broadband access. 4G LTE speeds are up to 100 megabits per second with ranges up to 10 miles. 5G speeds are up to 20 gigabits per second in ideal conditions, but only have a range of about 1,000 feet. However, in real-world scenarios, average download speed is typically 100 to 300 megabits per second. 5G offers low latency and high speeds. It offers high mobility and rapid deployment, but it is dependent on cellular coverage. You may have data caps on higher costs for extensive use. It is often used in mobile offices, temporary sites, and backup connections. Microwaves are electromagnetic waves which have a frequency range between 1 GHz to 300 GHz. Microwaves can travel up to 30 to 40 miles or 48 to 64 kilometers, although not as long as high-powered radio waves. Microwave signals can deliver data rates ranging from 300 megabits per second to 25 gigabits per second, and even higher in some specialized scenarios. It is unidirectional in nature, which means that they can travel only in straight lines. It requires a clear line of sight between the transmitting and receiving antennas. These high-frequency signals do not penetrate into walls. These waves are usually used for one-to-one communication between sender and receiver, cellular phones, and wireless LAN. Satellite is a form of radio networking where it is non-terrestrial communications using high frequencies 1 to 30 gigahertz. Satellites can provide coverage over vast geographical areas, including remote and rural regions. Satellites may be necessary for remote sites and difficult to network sites. Similar to other microwave communications, satellite communication requires a clear line of sight between the transmitting and receiving antennas. It has a high cost relative to terrestrial networking. Typical speeds may be 50 megabits per second down and 3 megabits per second up. Due to the long distances that signals must travel from the Earth to the satellite and back, satellite communication often experiences high latencies compared to terrestrial microwave links or other forms of communication. High latency being 250 milliseconds up and 250 milliseconds down. Because of latency, jitter may occur, which is caused by a variation in delay of packet transmission over a network. You need to connect two buildings located miles from each other, use fixed directional antennas, and increase signal strength. It provides point-to-point connection and has minimum signal absorption or bounce. It requires outdoor antenna installation, which is not trivial and should be done by an expert. Many wireless technologies, including cell phones and 802.11 Wi-Fi, use a cellular topology where an area is divided into cells. A broadcast device is located at the center and broadcasts in all directions to form an invisible circle or cell. All network devices located within the cell communicate with the network through the central station or hub. Cells are interconnected with the rest of the network infrastructure. If cells are overlapped, devices may roam from cell to cell while maintaining connections to the network. A dead zone is an area that isn't receiving cell signals. It's caused by being too far away, being blocked by a building, mountain, or something else in the environment, or in an area that does not have coverage. In wireless networks, there are 4 types of networks: mesh, ad hoc, point-to-point, and infrastructure. Point-to-point is a dedicated connection between 2 devices only, typically used for long-distance, high-bandwidth links. It requires line of sight between the 2 devices. For example, a wireless link between 2 buildings using dedicated microwave antennas. Mesh refers to a network where devices connect directly to multiple other devices, creating a flexible and resilient network with no single point of failure. It offers decentralized connectivity, whereas every node acts as a repeater or router. It has multiple nodes that connect to each other directly, creating redundant pathways for data transmission. It is self-configuring and self-healing as nodes automatically discover each other and form connections, and the network can reconfigure itself when nodes are added or removed. It is well suited for large areas with the potential for dynamic changes in network topology. Examples include smart city infrastructure, where sensors communicate with each other across a wide area. Ad hoc, also known as Independent Basic Service Set, or IBSS, describes a temporary peer-to-peer network where devices communicate directly without a central access point. Devices connect directly to each other without a central access point, often used for temporary setup like file sharing between nearby devices. Example includes a group of people sharing files during a meeting using their laptops. Infrastructure describes a network that relies on a central access point for devices to communicate through. Devices connect to a central access point, like a wireless access point or wireless router, to communicate with each other. Most common types of wireless networks offering centralized management and control. For example, a home Wi-Fi network where all devices connect to a single router. A wireless access point, or AP, is a networking device that allows wireless devices like smartphones, laptops, and tablets to connect to a wired network, essentially acting as a hub that enables them to access the internet by bridging the gap between wireless and wired connections using Wi-Fi technology. It's a central point for wireless communications within a local area network, or LAN. It typically connects to a router or network switch using an Ethernet cable, which will allow internet access through the wired network. For larger areas, organizations may need to install multiple wireless access points to provide full coverage. These devices would typically manage with a wireless controller or cloud controller, or could be deployed as part of a mesh architecture where the mesh nodes would connect to a root node that acts as a gateway for internet access. Wireless access points need to be secure too, but the security may be limited by the need to provide coverage and accessibility. You may consider placing the wireless access points in a secure room, but they usually need to be placed where they can cover the clients. Therefore, install your APs in a central location away from any corners, walls, or other physical obstructions if possible to provide maximum signal coverage. For larger places and/or multiple floors, you may need to place multiple access points. You may consider placing them in high points in the office or building. Remember that you may need to power cycle the wireless access points, so place them where you can get to them. A wireless router is a device that not only provides wireless access like an AP, but also manages the network traffic and acts as a gateway to the internet, typically including features like firewalls, router, DHCP services, DNS servers, and network address translation, or NAT. Wireless routers are commonly used in homes and small offices to provide internet access to various devices like laptops, smartphones, and tablets, and typically includes Ethernet ports for connecting wired devices like desktop computers with a twisted pair Ethernet cable with an RJ45 connector. Radio frequency identification, or RFID, uses radio waves to identify people or objects. The reader is a device that reads information contained in a wireless device or tag from a distance without making any physical contact or requiring a line of sight. Radio energy is transmitted to the tag, which powers the tag, and ID is transmitted back. There are two types of RFID technology. Vicinity RFID-enabled documents can be securely and accurately read by authorized readers from up to 20 to 30 feet away. Proximity RFID-enabled documents must be scanned in close proximity to an authorized reader and can only be read from a few inches away. Examples include access badges, inventory or assembly line tracking, pet or animal identification, and electronic tags placed on clothing and other items in a retail environment that sounds an alarm when an item is removed from the premises. RFID uses several frequency bands. The most common being low frequency, or LF, around 125 to 135 kilohertz. High frequency, or HF, at 13.56 megahertz, often for the near field communication, or NFC, and ultra high frequency, or UHF, between 860 and 960 megahertz. The specific frequency used depends on the application, as each band offers different advantages in terms of read range, data transfer rate, and tag costs. Question: you need to support a remote area that does not have a network infrastructure, including cable or DSL. What is the best solution without adding external infrastructure? Answer: satellite. Question: you need to recommend an internet connection for a customer who travels around the world and wants to have connectivity while visiting remote camping locations. Some of the locations the customer visits have limited or unreliable cellular service. Which of the following connection types would you recommend? Answer: satellite. Question: which has the highest latency? Answer: satellite. Question: you need to connect two laptops directly to each other using 802.11 AC, but does not have an AP available. Which of the following describes this configuration? Answer: independent basic service set. Question: what is independent basic service set known as? Answer: ad hoc. Question: which of the following network devices converts wireless signals to electronic signals? Answer: access point. Question: which of the following answers refer to the key features of wireless ad hoc networks? Choose two answers. Answers: temporary connections and direct links without an AP. Question: which of the following wireless technologies would a company most likely implement for inventory management? Answer: RFID. Question: you have a customer that has a Wi Fi capable laptop to use when traveling for work. Which of the following will allow the laptop to stay connected when the user travels? Answer: cellular card. For more information, refer to these sites. In summary, wireless technology provides the ability to communicate between two or more entities over distances without the use of wires or cables of any sort. Cellular broadband, such as 4G and 5G, uses mobile networks for broadband access. Satellites can provide coverage over vast geographical areas, including remote and rural regions, and may be necessary for remote sites and difficult to network sites. Satellites have high latency. Many wireless technologies, including cell phones and 802.11 Wi Fi, uses a cellular topology where an area is divided into cells. A wireless access point, or AP, is a networking device that allows wireless devices like smartphones, laptops, and tablets to connect to a wired network, essentially acting as a hub that enables them to access the internet by bridging a gap between wireless and wireless connections using Wi Fi technology. A wireless router is a device that not only provides wireless access like an AP, but also manages network traffic and acts as a gateway to the internet, typically including features like firewalls, routers, DHCP services, DNS services, and network address translation or NAT. Radio frequency identification, or RFID, uses radio waves to identify people or objects, which is often used in access badges, inventory, assembly line tracking, pet identification, and electronic tags. Thank you for watching this video. The next video will be Networking Part 6, Wireless Networking Part 2. If you like this video, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.